In this lesson, we're going to answer a very important question. What is a computer network? Before we talk about routers, IP addresses, or troubleshooting commands, we need to understand the most basic idea first, because everything in networking builds from this definition. So let's start simple. A computer network is a group of devices connected together so they can communicate and share resources. That's it. Devices, connected, communicating. But inside that simple definition is a lot of power. Imagine if your computer was completely isolated. No internet, no shared printer, no shared files, no cloud storage, no email. It would be limited to whatever is physically stored on it. Networks exist to remove that isolation. They allow devices to share information, share services, share resources, access the internet, communicate in real time. Without networks, modern businesses would not function. Cloud computing would not exist. Remote work would not be possible. Streaming, online banking, video conferencing, none of it works without networks. So, networking is not just about cables and routers, it's about enabling communication. Every network, no matter how large or small, has three fundamental components: devices, media, protocols. Let's break each one down. Devices are the endpoints and infrastructure components that make communication possible. There are two major categories. End devices are devices that generate or receive data. Examples include laptops, desktops, servers, smartphones, printers, IP cameras, and Internet of Things devices, or IoT. And devices are sometimes called hosts because they host applications. Network devices move data between devices. Examples include switches, routers, firewalls, wireless access points. End devices create the data. Network devices move the data. Media is the pathway data travels on. There are two main types: wired media, such as copper cables, like Ethernet cables, and fiber optic cables; wireless media, Wi Fi, cellular signals. The media carries electrical signals, light pulses, or radio waves. Without media, devices cannot physically transmit data. Think of media like roads. Devices are cars. No road, no movement. Protocols are the rules that devices follow when communicating. If two devices don't agree on the rules, communication fails. A protocol defines things like how data is formatted, how devices identify each other, how errors are handled, when is data sent. For example, HTTP allows web browsers to request web pages. DNS translates names into IP addresses. TCP ensures reliable communication. Protocols are the language of networking. Devices don't just send data randomly, they follow structured rules. Let's put together a familiar scenario. You open your laptop and connect to Wi Fi. Your laptop sends a request to your home router. Your router forwards that request to your internet service provider. The request travels across many networks until it reaches the web server. The web server sends data back. Your router receives it. Your laptop displays the web page. What just happened? Your laptop is an end device. Your router is a network device. Wi Fi is the media. HTTP, IP, and TCP are protocols. That's a network in action. Not all networks are the same size. A small home network might have 5 to 15 devices. A business network might have hundreds or thousands of devices. The internet is the largest network in existence. It is literally a network of networks. That's what the word internet means: interconnected networks. Within a network, devices often have roles. A client is a device that requests services. A server is a device that provides services. When you visit a website, your computer is the client. The web server is the server. When you print, your computer is the client. The printer acts as the service provider. Understanding these roles become important when we talk about addressing and troubleshooting later. There are two main types of communication. Local communication are devices on the same network talking directly. Example, your laptop printing to a printer on the same Wi Fi. Remote communication are devices on different networks communicating through routers. Example, your laptop accessing a website hosted in another country. This distinction becomes critical when we discuss IP addressing. Networking is unique because it operates in layers. We don't send a message, we send data wrapped in structured layers. Each layer has a responsibility. This layer design allows scalability, interoperability, easier troubleshooting, standardization. In the next lessons, we'll explore those layers in detail. Let's correct a few beginner misconceptions. A network is not just the internet. A network does not require Wi Fi. A network is not just one cable. A network does not require a router, though routers are required to connect multiple networks. At its simplest form, two computers connected with the right configuration can form a network. The CCST exam begins with fundamental building blocks of networking. If you deeply understand what a network is, everything else becomes easier. Addressing makes sense, routing makes sense, switching makes sense, troubleshooting makes sense. If this definition is fuzzy, advanced topics feel overwhelming. So this lesson is not simple, it's foundational. Let's recap. A computer network is a group of devices connected through media, following protocols so they can communicate and share resources. Devices create and receive data. Media carries the signals. Protocols define the rules. That's networking. In the next lesson, we'll begin breaking down how communication is structured using networking models. And that's where things start to get really interesting. Let's continue building.